Hello, everyone. I am assuming everybody is joining in. Okay, hello. I hope you had an amazing Friday so far and you're going to conclude it with this amazing chemistry session. As you all know, the topic of our chemistry webinar is stoichiometry, but before I start, I would like to introduce myself. I am Kirandeep Kaur and I'm a tutor at Reset Learning. I have recently joined the team and I'm really thrilled to be here and presenting in front of you all virtually. And I hope that you all are able to take away some fundamental understanding of stoichiometry by the end of this session. The concepts that we will be learning today would be balancing chemical equations, understanding moles and molar mass, atoms to mass stoichiometry calculations, limiting and excess reactants, and real-world applications of stoichiometry. We will be having a Q&A session at the end, so if you have any questions, please write them down or have them in the back of your mind, and feel free to put them in the chat once I'm done talking about all the slides, and we'll also have a wrap-up session after that. All right. What is stoichiometry? In general, what does it really entail? Why are we learning it? Why is it important? It is a fundamental concept that you will be seeing if you're taking chemistry 11 or chemistry 12, or even if you take a bachelor's in science. It is a quantitative study of quantitative relationships between the reactants and products in a chemical reaction. So if you look here, we have our reactants, which is CH4 and O2, and then we have our products on the right side, which is CO2 and water. So the study of understanding the relationship between the reactants and products is basically your stoichiometry. It also is fundamental for predicting the amount of products and reactants that are involved in a chemical reaction. All right, so balancing chemical equations. If you have taken Science 10, you would know that this is a very, very important concept. We cannot start solving any of our chemical equations if our balancing is not done. The reason that is why is because of law of conservation of mass. Again, mass cannot be created or destroyed, which means the mass of the reactants must always equal the mass of the product. So if you look at my example right here, we have methane and oxygen, and then we are producing carbon dioxide and water. Both of them, when I calculated their mass, I got 80 grams for reactants and then 80 grams for product. Again, that means I have balanced my equation and my law of conservation of mass has been applied on this reaction. Okay, but how do we really do so, right? Like, we are talking about balancing, but we need to know how can we do that. What is the easiest way to balance an equation? I will be following this slide with examples, so just if you want to note these down, feel free to write notes in your notebook, or yeah, just have it in your backlog. Again, the first step is write the unbalanced equation, which would be our given equation. Then second step is we will balance atoms one at a time. So we will start with the most complex molecule, and then we will move to the most easiest molecule, which is an element itself. So this one, C3H8, is itself a compound. So we can start with C3H8 and then we can move to the oxygen because oxygen is by itself. And then we will do a tally on both ends, which is your reactants and products, to see if both of them are balanced. So if I look at an example right here, we have hydrogen and oxygen, which makes water. We have 2 hydrogens on my reactant side, and we have 2 oxygens on my reactant side as well. But if I look at my product, I have 2 hydrogen, which is great. That means my hydrogen are balanced, but my oxygen is not balanced, right? We only have 1 oxygen here. So we will have to do some work here to make sure that both sides are equal or equally balanced. So in this case, the easiest way is to put a coefficient, which is 2, in front of the water molecule, which will also change your amount for hydrogen. So this will become 2 times 2, which is a 4. You will have to put a 2 in front of this hydrogen as well. And then oxygen is also 2 on my right. So now we have a balanced equation. I will again show you more examples that will help you to kind of do it in a table format. I usually see that students benefit from doing it in a table format because you can tally on both sides, but this is another way to do it if you want to just do it like on the spot. Okay, so these are more examples. Again, if you see, I have divided my equation into two components, one reactants and then one product. So let's start with this equation here. We have 3 carbons here. We have 8 hydrogens and we have 2 oxygens. Again, these are all balanced equations. We have 2 hydrogens on my right. We have, again, 2 plus 1, which is 3 oxygens and 1 carbon, right? So sorry, this one is an unbalanced equation, so we have to balance it, right? So I will have to now see what I can do to my carbon here that becomes a 3. I would again start with your carbon, then move to your hydrogen and oxygen. We did look at this equation in the last slide too. Let me just pull it up. So right here, right? So we did start with our C3H8 and we had to make some changes to our oxygens because again, oxygen was not balanced on both sides, and then same for water, which entailed our hydrogen. So this was my unbalanced equation before I added the coefficient 5 here. Okay, so let's look at this example. We have N2, H2, and NH3. In this, before I balanced it, I had 2 nitrogens and 2 hydrogens, 1 nitrogen, and 3 hydrogens. That means, again, nitrogen is not balanced, clearly, because this one has a 2, this one just had a 1. Hydrogen is also not balanced because hydrogen has 2 here, and we have 3 hydrogens on my product. So we'll do the tally again. What can I add to my hydrogen so my hydrogen on the product side also gets balanced? But before I even move to hydrogen, the easiest way is, we know that nitrogen is 2. How about we just put a 2 here and see where that takes us? Once I add a 2 as a coefficient here, we'll have 6 hydrogens now. And then that's just easy because then I can just put a coefficient of 3 here, which also makes hydrogen a 6. Now my equation is balanced. It is a lot of trial and error. So you might have to sometimes try, it might take few turns before you get the whole balanced equation, but if you put it as your, again, left and right tally, it's easier to follow along. Again, please make sure that you're only adding a coefficient. You're not changing these subscripts. You cannot change these subscripts because this subscript is how many atoms of that element are present. The coefficient right here is my how many molecules, so how many groups of hydrogen do I have? Okay, please ensure that. It's a very common mistake. Try not to touch these subscripts at all. Okay, now going into the real concept that I do want to touch after balancing is, what is a mole? Mole is a very important part of stoichiometry. 1 mole equals to 6.022 times 10 to the 23 particles, which is also known as Avogadro's number. Everything around us is, we know everything around us is made up of particles, which entails mole, right? So 1 mole contains 6.022 times 10 to the 23 particles. So mole concept relates to the amount of substance in terms of atoms or molecules. Similarly, molar mass is the mass of 1 mole of a substance. So if you look at your periodic table, you will see that you have a molar mass or a mass associated with each element. That mass is for each 1 mole. So say if it's 32 grams, that's 32 grams per mole. I have an example here for you all. So how many moles are in 32 grams of oxygen? Your molar mass of oxygen is 32 grams per mole. Again, I just took this from the periodic table. 1 oxygen is 16, but we have 2 here because this is a diatomic element, which means it exists in pairs. That made me get 32, which is 16 plus 16. So 32 grams of oxygen is 1 mole. All right, so that's how molar mass works and what mole and molar mass have that connection. But we also need to figure out mole ratios because we have a chemical equation now. We need to make sure, due to law of conservation of mass, we need to make sure everything on my reactants and products side is equal. Okay, so what is mole ratios? The ratio of moles of reactants and product is based on the coefficients of a balanced equation. Again, that's why I started with the balancing equations, because all the concepts I'm doing right now are built onto each other. They're all connected. So let's look at an example. Lead reacts with copper sulfate. If 9.78 moles of copper is produced, how many moles of lead is reacted? So again, first step, always start with a balanced equation. Lead is Pb, copper sulfate is Cu2SO4, which will give me lead sulfate plus copper. This is a single replacement reaction, for you all wondering. So again, what is given to us? We were given copper, which is 9.78 moles. So we're gonna write the given, whatever it is, and we're going to multiply it by our desired. Our desired is what the question is asking us to find. So the question is asking us to find the moles of lead. So we're going to put the desired on the top and our given on the bottom. Our given is the copper. So now let's find our moles of Pb. When I balanced it, it was 1 to 1 to 1 to 2. So for every 1 mole of Pb, I require 2 copper. So my 1 mole of Pb then goes on my top because that's my desired. Anything you're trying to find will always go on the top of your fraction. And because I want to cancel out my copper, that will go on the bottom, which is also our given. So there's 2 moles of copper. When I calculate that, I'm basically just dividing 9.78 mole with 2 moles of copper. My copper and copper will cancel. The only thing left on the top would be mole of Pb, which is exactly what we're finding. We'll get 4.89. Again, if you know the concept of sig figs, your coefficients, which is the moles, do not contribute to your sig figs. It's the given number that contributes. In this case, we will have to report our answer in 3 sig figs. Okay, let's look at one more example. If 3.45 mole of copper sulfate reacts, how many mole of lead sulfate are produced? Again, our given goes on the left side of our fraction. Whatever we're trying to find is our desired, goes on the top. And then whatever we're trying to cancel out, which is basically the given, goes on our bottom of the fraction. So in this case, everything is just 1 to 1 in for copper and Pb sulfate, so we don't really have to do any further calculations. We can just say 1 mole of Pb sulfate over 1 mole of copper sulfate. Your copper sulfate will cancel on both sides. The only thing left is Pb sulfate, which is what we were trying to find. So your answer is just 3.45. So again, for every 1 copper sulfate, you need 1 lead sulfate. So it's 1 to 1 ratio. Okay, I'm gonna just also put this in wording because I know some people like it when it's, theoretical. So the definition for your mass, again, the word amount refers to the number of moles of substance present in any given mass. The word mass refers to the mass in grams of substance present in any given number of moles. And then molar mass is used for as conversion factors, which is the fraction that we were looking at, that allows us to convert from mass to moles and vice versa. Okay, again, the molar mass of a compound is the sum of your atomic molar masses. This is coming from your periodic table in that compound, and the units are always grams per mole. Okay, so the symbols for mass for mass, it's just lowercase m. Moles is lowercase n. Avogadro's number is n to the a. Okay, and molar mass can also be mm. Again, these are non-units. These are just symbols. Okay. Awesome. So now let's look at, we know what mole is now. We know what molar mass is now. We know what Avogadro's number is. But we have to put this into practice now. We know the theory, we got to apply it. right? So Avogadro's number can actually be used as a conversion factor. What does that mean? If your question is asking you how many atoms are present in n number of moles, you'll have to use your Avogadro's number. Let's look at example. So how many lithium atoms are in 3.2 moles of lithium? Now our given is basically mole. Remember the fraction I told you before? You will always have your desired on the top and your given on the bottom. Okay? So in this case, you don't really have to do a balanced equation because it is only talking about the same atom or same element. We don't really have a chemical reaction happening here. So we'll start with 3.2 mole. We'll multiply it by Avogadro's number because we need atoms. So this is the conversion factor we are using, which is 6.022 times 10 to the 23 particles over mole. And we're just going to cancel mole and mole. The answer when you do that is 1.9 times 10 to the 24 atoms. Again, you will see that I'm using different terminology with each question. Particles, atoms, ions, all of them are the same thing. Okay, don't get confused with that because it's the same analogy. It all comes under the same category. Okay? Okay, let's look at one more example. Find the number of chromium ions in 3.5 moles of chromium ions. Again, now we've been given moles and we've been told to calculate for ions. Our Avogadro number has to go on the top because that's the desired. So mole and mole will cancel. When you multiply these two, you will get 2.1 times 10 to the 24. Again, I have two sig figs here. It's because in our given we had two sig figs. If you have questions about sig figs or any concept that I'm talking that you don't know, you can please feel free to email me after as well, because this is an overall concept that I'm covering. But yes, if you want me to kind of go deeper into these concepts, I can also help you later. So how many atoms of sodium chloride are in 0.23 moles of NaCl? NaCl is salt, as we all know. So again, same thing. Our desired goes on the top. What's given, what we're trying to get rid of, goes on the bottom. So 0.23 mole times 6.02 times 1023 atoms goes on the top. Mole and mole cancel. When you put this in your calculator, you'll get 1.4 times 10 to the 23. Okay, sorry, I have a lot of examples because I think it really helps putting the theory into practical. Feel free to again make notes if you need to. This will also be posted later, so you can always come back to it. So now let's switch things up. Last time we were being asked how to calculate atoms from moles. Let's do one thing. Let's go from atoms to moles this time, and we did moles to atoms last time. So now we're given atoms, which is 1.81 times 10 to the 22. So again, that's my given. Whenever you see that something is given to you, it also goes in the bottom of your fraction, conversion factor, right? And what we're desiring, what the question is asking us to find, always goes on the top. So in this case, we're being told to find moles, so that will go on the top. So again, 1 mole has 6.02 times 10 to the 23 atoms. Your atoms and atoms will cancel. When you divide this number with your Avogadro's number, you'll get 0.030 moles of argon. One other way of ensuring that you're on the right track, your moles will never be a really big number. It will always be a small number compared to your particles, because particles, 1 mole equals 6.02 times 10 to the 23 particles. That itself is a very big number, right? So that's another way of ensuring that you're on the right track. Alrighty, let's look at this question. How many moles of hydrogen are there in a mole of water? How many moles of oxygen are there in a mole of water? So now, two questions. Hint, what is the ratio of hydrogen atoms to the oxygen atoms? Now we're looking at hydrogen, oxygen making water. So we have to kind of look at the whole compound. H2O, we have 1 oxygen and 2 hydrogens. So 1 mole of water will actually have 2 moles of hydrogen. Okay, and we have looked at this as a chemical reaction too, right? H2 plus O2 gives you water in the previous slide. Okay, one last question on this topic. So 1.4 times 10 to the 18 silver, which is Ag, atoms represent how many moles of atoms? Same thing. They've been told us to, they're asking us to find moles. It's my desired. It will go on my top of the fraction. What is given to me goes on the bottom. So I have been given atoms, so I will have to find a ratio for atoms, which is the Avogadro's number. When you divide these two numbers, you'll get 2.3 times 10 to the negative 6 moles of silver. Awesome. So now we've looked into atoms to moles, moles to atoms. We've also looked into moles to mass. Let's look into mole to mass more deeper, okay? Now, I talked about molar mass. We will actually be using molar mass really heavy for this section. So how can I use molar mass to obtain the mass of a substance if I knew the amounts of moles of that substance? Okay, so if I want my mass, it is my desired. My mass will always be in grams. For my conversion fraction, the gram will always have to come on my numerator, which is on the top of the fraction, and mole will always come on the bottom because we're trying to cancel out that unit. Okay, so what is the mass of 2 moles of NaCl? I will write 2 moles on my left. I will have to go to the periodic table, find my molar mass. So sodium and chloride, when you combine it, you get 58.5 grams per mole. The mole and moles cancel. You'll do 2 times 58.5 and you'll get 117 grams. I have rounded this off because of the sig figs. There are 2 sig figs. I wanted 2 sig figs, so I put 120 grams. So this will make 2. Again, if you don't know how to calculate molar mass and you need more help, please feel free to email. I can look deeper into that. So how can I use molar mass to obtain the amount of moles if I knew the mass? Again, now I know the mass. I'm trying to find my moles. Moles will go on the top because that's my desired. Grams will go. So you'll flip that fraction. So you know how we have 58.5 over 1 here? In that case, if I were to find my moles, it would become 1 over 58.5. Okay? So when I did the molar, when I added all this individual masses of these elements, I got 33 and combined them, I got 331.2 grams per mole. Again, I was told to find how many moles are there. I multiplied 5.6 with 1 over 331.2. That gave me 0.017 mole. Again, I have 2 sig figs. That's why I have 2 sig figs here. Okay. Okay, more practice. So ethylene, which is C2H4, it reacts with oxygen to produce carbon dioxide and water. Anytime you see that you've been given elements or reactants and you've also been given your products, that's an indication you have to start with a balanced chemical equation. Okay, if you start with 50 grams of ethylene, how many grams of carbon dioxide will be produced? This is a combustion reaction. The reason for that is because you have your products have carbon dioxide and water. This comes under the type of chemical reaction, so it is a combustion reaction. Okay, I had to balance this. We had 2 carbons, so we will always start with carbon first. Whenever you have carbon, hydrogen, oxygen involved in a chemical equation, always start with carbon, then hydrogen, then oxygen. And that makes sense here because I told you how start with the most complicated compound. Okay, so I want to make this a 2 because this is not a 2, this is a 1, so I'll just simply add a coefficient 2. Let's see what it did to my other equation. Now I have 2 oxygens here. I don't have 2 oxygens here. I have well, I have 2 oxygens here and I have 2 plus 1, so 3 oxygens, so I don't have 2 there, so that needs to be fixed. But because we added this 2, now we have 4 plus 1, which is a 5. That's an odd number. So you can have fractions, but I prefer not to. I always prefer leaving it whole numbers. It makes your calculations more easier. Hydrogen is 4 here. So let's start with hydrogen. Remember, we'll go from carbon, then hydrogen, then oxygen. So let's not worry about oxygen till the end. So we have 2 hydrogens. So let's just put a 2 here because that will make it a 4. Now let's see, did it change my oxygens? 2 times 2, 4 here, plus 2, it's a 6. Great. I know there's an O2 here. I can put a 3, which will make it a 6 on my left side too. It's balanced. Okay, now we have moles. Now we're going to use this mole to find what the question is asking us. The question has given us the mass. Okay, so mass will go on the left side. It's asking us to find how many moles are um, produced, right? How many, yes, how many moles are produced? So let's look at C2H4. So 1 mole over 28 grams. This is coming from a periodic table. I found my molar mass for C2H4 because that's given to me. So once I did that, I got 1.79 moles of C2H4. So how many grams of CO2 produced? So to find that, you will have to do your mole ratio. So once I got my moles of C2H4, now I have this. Okay, because they didn't directly give it to us, so we could just do the mole ratio. We had to find the moles first. Now we do the mole ratio. Okay, let's do it with carbon dioxide. So for every 1 mole of C2H4, I need 2 moles of carbon dioxide. So 1.79 times 2 mole over 1 mole. Again, desired goes on the top, what's given goes on the bottom. You'll cancel it out. You'll get 1.79 times 2, which is 3.58 moles of carbon dioxide. So we found the moles produced for carbon dioxide, but the question is actually asking us grams, in grams. So I will have to convert my moles to grams. So my last step would be using the molar mass. So you're going to use the molar mass for carbon dioxide, which is 44 grams. Moles and mole cancelled. When you multiply these two numbers, you get 158.9 grams. Okay, so that's my final answer. Again, do you see how I like divided that into steps? It's easier when you do it stepwise. If you want to do it all together, you could do this whole thing together too, but I like to do it separate because it helps me kind of check my work. Okay, let's see. Okay, I'll quickly go over this example. This is a photosynthesis equation. We have CO2, we have water, glucose, which is C6H12O6, and oxygen. So when I balanced it, I got 6, 6, 1, 6 as my coefficients. In this case, they gave us the mass of glucose. They're asking us to find the mass of water. So I will have to do my mole conversion first from my mass. So when I calculated the molar mass of glucose, I got 180 grams per mole. Again, because they're asking us to go from mole to mass, I will have to convert glucose mass into moles, okay? And then do my mole ratio. So when I did that, I got 0.0700 moles. Now I can do my mole ratio, which is for every 1 glucose, I need 6 hydrogens. And it's asking us how many grams of water. So water will have to go on the top. So this becomes 6H2O over 1 because we only have 1 here. This cancels. I got 0.420 moles of water. Now, last step, do not forget, we still have to give them grams. So we will have to use the molar mass. So molar mass of water is 18. So 18 grams over mole. Again, grams goes on the top because that's what they're asking us to find. Mole cancels. We'll have 7.56 grams of water left. Okay. Again, this question, if a plant needs to consume 36 grams of water, how many grams of carbon dioxide were consumed? Same thing you will do. You will first convert your grams of water to mole, and then use that molar ratio to find the moles of carbon dioxide, and then multiply it by the molar mass of carbon dioxide. The answer should be 88. Okay, so we're more than halfway there. We figured out how to convert particles to moles, and we figured out how to convert moles to mass. But what if the question is asking us or given us particles and is asking us to find the mass? We will have to take a layover. Okay, our layover will be our moles. Okay, you cannot, there is no direct flight. You will have to make a stop in between. Okay, so our midway is moles. You will have to first convert your particles to moles, which is either by, well, dividing it by your Avogadro's number and then going to mass, which is grams per mole. If your question is asking to go from mass to particles, you will have to multiply it by mole over gram and then multiply it by Avogadro's number. So everything we've learned so far, we're going to combine all those concepts to do that. Okay, again, simple rule: multiply by the unit you want, divide by the unit you don't want. Again, desired goes on the top, and the given that's given to you that you don't want goes on the bottom. Okay, conversion problems for molecules to mass. So this is the multi-step conversion that I was talking about. It's asking you to find the mass of 1.5 times 10 to the 15 molecules of silver chloride. Now, remember I told you particles, atoms, ions, compounds, molecules, same thing. Okay, all same vocabulary for the same category. So let's go stepwise. We will have to make a stop. We have to have a layover in mole. So we'll have to make a stop there. So let's first convert our molecules to mole. Okay, mole goes on the top, Avogadro's goes on the bottom. Molecules cancel. When you divide these two numbers, you get 2.5 times 10 to the negative 9. Now, last step, we go from moles to mass. So find the molar mass of AgCl. I got 133.4. I think I misput that. You will multiply it by your molar mass and then you'll get your final answer. Okay. Again, why is it that? Because it's grams per mole. Your grams will go on the top because your question is asking you to find the mass, which has to be in the grams. Okay. Now, how many molecules are there in 4 grams of silver chloride? Same thing. You've been told to find your molecules, but you've been given your mass. So now you have to go backwards. So let's convert your mass to moles, because moles is our, midway, our layover. So 4 grams times 58.5, which is molar mass of NaCl. I got my moles, which is 0.0684, and then you'll multiply it by your molecules, and you'll get your final answer, which is 4.12 times 10 to the 22 molecules. So this is the multi-step conversion, okay? All right, we're almost there. So another thing that we do need to kind of consider, stoichiometry also helps us figure out what is limiting, what is excess. So which of the reactant will run out first, which one that I have is in excess. So what is limiting? The reactant that is completely consumed in a reaction and limits the amount of product formed. So the one that runs out first is your limiting. Excess is the reactant that is not completely used up in a reaction, that you're still left with. Okay, so if there's 5 moles of hydrogen and 3 moles of oxygen, which is the limiting reactant in the reaction 2H2 plus O2 2H2O. Again, hydrogen is our limiting reactant. There is another way of looking into this. We will do the calculations, but for now I want you to sit with this concept because we have already done moles to mass and vice versa. So I don't want to overwhelm you all with more calculations. But yeah, H2 is your limiting reactant for this equation. And yeah, so in this case, let's look at a realistic example. I have 5 hot dogs. I have 2, 3, 4, 5, 6, 7, 8, 8 buns. When I used the buns to make my hot dog, I was left with 4 hot dogs. There was 1 leftover hot dog. So that means my bun was my limiting reagent here. And the one that I was left with that I couldn't really use up was 1 hot dog, which would be my excess reagent. Okay. If you're interested in going deeper in this topic, please email us, and I can also provide some resources for that. Okay, let's conclude it by why do we really care about this? How is this applied in real life? So it's actually applied in everyday chemistry. So pharmaceutical industry, so when you go to get your medicines, they have to do their dosage calculations. They use stoichiometry to do that. Food production, so ingredient ratios, right? When you're cooking something, so if you're baking cake, you would need to know how much, how much milk you're using, or whatever you're trying to make, you need to make sure how much ingredients you're using and how much product that will make you, so how much of that food you would be able to make through it. And then environmental science, so pollution control, again you need that stoichiometry for that. And that's it for me, but this is our Q&A, so if you have any questions, please feel free to leave them in the chat. Again, if I do not have enough information, as I said various times, I will get back to you through email, and feel free to email us at this email address right here. Thank you so much for joining. And one last thing, do not forget to get your participation certificate. You can send us an email right here on this email address. This QR code will also take you guys to the website, and you can get more information there. Awesome. Thank you. Let's see if we have questions. No. Okay, awesome. Thank you so much, everybody. Have an amazing Friday. Thank you for joining.
Perfect.
Good.
خلاص